Welcome to lesson number 3, metric conversions. Our objectives for this lesson: convert between units of measurement and convert between Celsius and Kelvin temperature scales. If you recall, the metric system is the system of measurement used in science and in most other countries, and our base units of measurement can be found on reference table D. In the beginning of the year, the three most common base units are going to be the meter, the gram, and the liter, and as we progress in the course, we'll introduce more of these base units. And we can alter these base units to make the numbers larger or smaller, and we do that using prefixes. And so they use to modify our base units of measurement, and we can find them on reference table C. In reference table C, we have the symbol of the prefix, and then it gives us the factor. And the factors equal the number of base units. So one of any of these prefixes, 1 kilo, 1 deci, 1 centi, equals to the factor amount of those base units. So for example, if the base unit we're talking about is grams, we're measuring mass, then 1 kilogram, 1 kilo, is equal to 10 to the third base units, in this case 10 to the third grams, or 1,000 grams. If I'm measuring volume, then 1 milliliter is going to be equal to 10 to the negative third liters. So if I want to then convert between units, how do we do that? So let's look at an example. I want to convert 10.02 kilometers to meters. So we're measuring length. Our base unit is going to be meter. And so how do we convert? So the first thing we do is we take our starting amount, the amount that they give us, the number and the unit, and we're going to write that down. The next thing we're going to do is going to use table C to build our conversion factor. So we're going from km, kilometers, to meters. So here is our prefix, kilo, which is equal to 10 to the third base units, in this case 10 to the third meters. So 1 kilo equals 10 to the third meters. Now you'll notice that I put 1 kilometer, the kilo, on the bottom, and I put the base unit up top. There's a method to this, and what we do is whatever's on top here has to go on the bottom in our conversion factor. Why? Well, we want to be able to then cancel these out or cross them out. So if I have kilometers on top and kilometers on the bottom, when we divide by the same unit, they cancel out, and we're left with meters. That's what we're trying to get to. So the unit that's left is the one we're trying to convert to. And now we can cross out kilometers, and we get our answer. How do we do that? We take our starting amount, we multiply by anything on top, which is in this case 10 to the third, and divide by anything on the bottom, in this case 1, so it's not changing our answer. So 10.02 times 10 to the third, or 1,000, equals 10,020 meters. So let's see another example. I want to convert 45.50 milliliters to liters. So our base unit involved in this is going to be the liter, which is a unit of measuring volume. So I use my starting amount, which is 45.50 milliliters. I locate milli on table C, which is here. So we know 1 milli is equal to 10 to the negative third base units, in this case liters. That's our conversion factor. So 1 milli is equal to 10 to the negative third liters. Again, I put milliliters on the bottom because whatever's on top here must go on the bottom here, so they cancel out. And so I'm left with the unit of liters, which is the unit that I'm trying to convert to. And now simply multiply the top numbers and divide by the bottom. So 45.50 times 10 to the negative third divided by 1 is going to equal 0.0450 liters. Let's try one more example. We want to convert 502.3 kilojoules to joules. Okay, so now we're not working with those three main base units, the meter, the liter, or the gram. Nothing will change. It's still a base unit. We find joules on table D. So we do the same process. So I write the initial starting amount of 502.3 kilojoules. I locate the prefix kilo, which is over here. And we know that 1 kilo is going to equal to 10 to the third base units, which in this case is joules. We want to get rid of kilojoules to convert to joules, so kilo has to go on the bottom. So 1 kilo equals 10 to the third joules. So 1 kilojoule equals to 10 to the third joules. The kilos will cancel out, and I'm left with the unit I'm trying to convert to. And now I just multiply the top. 502.3 times 10 to the third, which is 1,000, gives me an answer of 502,300 joules. Okay, let's check our understanding. Let's see if you can convert between units of measurement. Okay, now let's look at temperature. Temperature is the measure of average kinetic energy, and if you recall, kinetic energy is that energy of motion. Now, all particles are in motion. In a colder environment, they're moving less, generating less kinetic energy, and therefore the average of that would be much lower and would record a lower temperature on our thermometer. In a warmer environment at higher temperatures, we have more motion, therefore more kinetic energy, which results in a higher temperature reading on the thermometer. Looking at our various temperature scales, the most common one you're probably used to is the Fahrenheit scale. We're not going to use that in this course. We're going to focus on the Celsius scale as well as the Kelvin scale, which you may not be familiar with yet. So let's look at the Celsius scale first. The Celsius scale actually was built around the freezing and boiling point of water. So simply the freezing point of water is 0 degrees Celsius and the boiling point is 100 degrees Celsius. And then anything below freezing, below 0, is going to be a negative number. And you have to memorize these values for this course. So again, the freezing point is 0, anything below that is negative, and then if you go up 100-degree interval, you get to 100, which is the boiling point of water. The Kelvin scale is simply the Celsius scale, just shifted up by 273 degrees or divisions. Why? Well, it gets rid of negative numbers. So some calculations we do this year, we cannot have negative numbers, and therefore the Kelvin scale eliminates those. So if we're shifting it up 273 degrees to get rid of those negative numbers, then water is going to not freeze at 0, but it's going to freeze at 273 Kelvin. And it's going to boil 100 degrees higher at 373 Kelvin. So then the lowest possible temperature you can possibly have on the Kelvin scale is going to be 0, and we call this absolute 0. It's a theoretical point which has not been reached where we believe all molecular motion would stop. So again, it avoids the negative numbers, but it has the same divisions or degrees between the freezing and boiling, just like Celsius, as we can see here. So there's still 100-degree intervals between those 2 points. And so in this course, we'll have to convert between those two temperature scales. And it's a simple calculation. If you look on the back of your reference table, table T, here's our formula, which is Kelvin equals degrees Celsius plus 273. So here's an example. What is the temperature in Celsius of an object that is 150 Kelvin? First thing we do in any formula is we write that out here, and then we're going to plug in the values and their units in the place that they belong. How do we know where they go? We follow the units. So the Kelvin goes in the Kelvin spot. We're going to solve for degrees C. How do we do that? We have to subtract 273 from both sides to get degrees C by itself. And so we get 150 Kelvin minus 273 is going to give us an answer of negative 123 degrees Celsius. So let's check your understanding. Can you convert between Celsius and Kelvin temperature? At this point, you should be able to convert between units of measurement and convert between Celsius and Kelvin temperature scales.